Let's solve another limit. Limit 1 over x plus 3 minus 1 over 3 divided by x as x approaches 0. Here, if we put x equals 0, the function becomes undefined. Therefore, we cannot solve it by substitution method. We have to simplify the numerator first. For that, we will use a rule known to us which says a over b minus c over d equals ad minus bc divided by bd. See, ad minus bc divided by bd. So we will apply the same rule for this numerator to simplify. So the numerator becomes 3 multiplied by 1 will be 3, minus 1 multiplied by 1 plus 3 will be minus x minus 3, and 3 multiplied by x plus 3 will be 3 multiplied by x plus 3, and this x will remain as it is. Now here 3 minus 3 will become 0, and the limit will become minus x over 3x plus 9 over x as x approaches 0. Now we can bring 3x plus 9 and this x together and write the limit as minus x divided by x multiplied by 3x plus 9. Here, as x approaches 0, x is not equal to 0. Therefore, we can cancel this x from numerator and denominator, and the limit becomes minus 1 divided by 3x plus 9 as x approaches 0. Now this limit we can calculate by substitution method by putting x equals 0 in place of x. So the limit becomes minus 1 divided by 3 into 0 plus 9, which will be minus 1 upon 0 plus 9, which will be minus 1 upon 9. Let's solve this limit. 1 over x minus 3 minus 2 over x squared minus 4x plus 3. Here, x approaches 3. If we put x equals 3 in this denominator and in this denominator, both will become 0 and the whole function becomes undefined. So we cannot solve this limit by direct substitution. For that, first we have to factorize this quadratic polynomial. How to factorize it? Here, the coefficient of x squared is 1 and the constant term is 3. So we will take product of 1 and 3, which will be 3, and we will find two factors of 3 such that their sum will be minus 4. Here 3 equals minus 3 multiplied by minus 1, and the sum of these two factors is minus 4. Next, we also have seen that whenever the coefficient of x squared is 1, with the help of these two factors, we can directly write the factors as x minus 3, see here, and x minus 1. We will use this factor in the next step. So the limit becomes 1 over x minus 3 minus 2 over x minus 3 into x minus 1. Here we have to solve this expression by common denominator method. Here we find that x minus 3 into x minus 1 is the common denominator of these two things. So, in order to solve it further, we will write the limit as x minus 1 minus 2 over x minus 3 into x minus 1. Now how this is done? First, we will divide x minus 3 into x minus 1, which is the common denominator, by x minus 1. So x minus 1 will get cancelled, and what remains is x minus 1. We will multiply this x minus 1 by this 1 and will write here. So here it will be x minus 1. Next, we will divide this common denominator, which is here also, by the common denominator itself, which will give us 1, and we will multiply this minus 2 by that 1, so it will become minus 2. In the next step, the limit becomes x minus 3 over x minus 3 multiplied by x minus 1. Here x approaches 3, therefore x is not equal to 3, and hence x minus 3 is not equals 0. So we can cancel x minus 3 from numerator and denominator and write the limit as 1 over x minus 1 as x approaches 3. Here we can solve this limit by direct substitution. So in the next step, we will put x equal to 3 in place of x. So it will be 1 over 3 minus 1, which is 1 over 2. Let us solve limit x plus 2 whole square minus 4 over x. Here we have x plus 2 whole square, so we have to expand this term. Moreover, as x approaches 0, if we put x equals 0 here, the whole function becomes undefined. So the first thing we have to do is to expand x plus 2 whole square. This we can expand by using an identity which goes like a plus b whole square equals a squared plus 2ab plus b squared. Therefore, in the next step, the limit becomes x squared plus 4x plus 4 minus 4 over x. Here 4 minus 4 becomes 0, so the limit becomes x square plus 4x over x. Next, we will take x common from the numerator, so the limit becomes x into bracket x plus 4 over x. Now as x approaches 0, x not equal to 0, therefore we can cancel this x from numerator and denominator. So the limit becomes limit x plus 4 as x approaches 0 will be 0 plus 4, which will be 4. In this limit, there are radical terms in the numerator and x in the denominator. X approaches 0. If we put x equals 0, this function will become undefined. Now we will have to rationalize the numerator. For that, we have to multiply the numerator and denominator by the rationalizing factor of this numerator, which is under root x plus 2 plus root 2. So we have to multiply this whole function by root x plus 2 plus root 2 divided by root x plus 2 plus root 2. Therefore, the function becomes, or the limit becomes, under root x plus 2 minus root 2 divided by x multiplied by root x plus 2 plus root 2 divided by root x plus 2 plus root 2. Now we have to multiply the numerator and denominator separately. For multiplying the numerator, we have to use the identity a minus b into a plus b equals a squared minus b squared. See here, this is a, this is b, this is a, this is b. So this is a minus b multiplied by a plus b. So its product will be root x plus 2 whole square minus root 2 square divided by x multiplied by root x plus 2 plus root 2. Next, the limit becomes x plus 2 because square of root x plus 2 will be x plus 2 minus square of root 2 will be 2 divided by x into root x plus 2 plus root 2. Here 2 minus 2 will become 0 and the limit becomes x divided by x multiplied by root x plus 2 plus root 2. Here x approaches 0, therefore x not equal to 0. So this x gets cancelled from numerator and denominator and the limit becomes 1 over root x plus 2 plus root 2. Now we can evaluate the limit by direct substitution. So we will substitute x equals 0 in the function and find 1 divided by under root 0 plus 2 plus root 2. That will be 1 over root 2 plus root 2, 2 root 2. So 1 over 2 root 2 will be the answer. Now we will understand how to find limits of piecewise functions. Now what are piecewise functions? Piecewise functions are defined differently in different sections of their domains. For example, consider limit fx as x approaches 1, where fx is defined as x square minus 1 when x is approaching 1 from left hand side, and fx is defined as minus x square minus 1 when x is approaching 1 from right hand side. Since x square minus 1 is approaching 1 from left hand side, we have to find left hand limit, and since minus x square minus 1 is approaching 1 from right hand side, we will have to find right hand limit also. So first we will find the left hand limit. For that we will choose this function x square minus 1 because x is approaching 1 from left hand side. So LHL equals limit x square minus 1 as x approaches 1 negative. This is a polynomial function, so we can solve this limit by direct substitution. So we will put x equals 1 in the function and find its limit. So it will be 1 squared minus 1, which will be 1 minus 1, and finally it will be 0. So the left hand limit or LHL is 0. Now x is approaching 1 from right hand side, and when it is approaching 1 from right hand side, the limit defined is minus x square minus 1. So for finding right hand limit, we will choose this function. So right hand limit will be limit minus x square minus 1 as x approaches 1 positive. This is a polynomial function. Therefore, we can find its limit by direct substitution. So we will put x equals 1 in this function. So the limit becomes minus 1 squared minus 1, which will be minus 1 minus 1, and finally it will be minus 2. Here we observe that LHL is 0 and RHL is minus 2. Since LHL not equals RHL, we say that limit fx as x approaches 1 does not exist. Now we will find limit of another piecewise function, which is defined as y equals fx equals x square minus 1 when x is less than or equal to 1. Fx is minus x square minus 1 when x is greater than 1. But before we find its limit, let us understand, or let us draw its graph first. So x-axis, y-axis, the graph of function x square minus y will be a parabola opening upwards. The vertex of the parabola lies on the y-axis, so we will put x equals 0 in x square minus 1 and find that y equals minus 1. So the vertex of the parabola will be 0 minus 1. This parabola will cut the x-axis at a point. As x equals 1, therefore y equals 1 square minus 1, that is 0. So the coordinates of this point will be 1, 0. The point 1, 0 will lie on the graph of the function. As x approaches 1 from left side, for finding left hand limit, we have to choose x square minus 1. So the left hand limit will be LHL equals limit x square minus 1 as x approaches 1 negative will be 1 square minus 1 equals 1 minus 1 equals 0. The graph of y equals minus x square minus 1 will also be a parabola, but because of this negative sign, it will open downwards. Its vertex lies on the y-axis, so we will put x equals 0 in minus x square minus 1 so that we will get y equals minus 1. Therefore, its vertex will also be 0 minus 1, which is same as the upper parabola. Now, let us draw a vertical line through point 1, 0. It will cut the lower parabola in 1 minus 2. Since x is greater than 1, the point 1 minus 2 will not lie on the parabola, so it has been shown by a hollow point. As x approaches 1 from right side, for finding right hand limit, we have to choose minus x square minus 1 and find the right hand limit as RHL equals limit minus x square minus 1 as x approaches 1 positive equals minus of 1 square minus 1, that will be minus 1 minus 1, that will be minus 2. Here we observe that LHL is 0 and RHL is minus 2. Therefore, since LHL not equal to RHL, we say that limit fx as x approaches 1 does not exist. Now we will understand how to find limit of a modulus function or limit involving modulus function. But before that, let us understand what is meant by a modulus function. Modulus function is defined as when x is less than 0, modulus x is minus x. When x equals 0, modulus x is 0. When x is greater than 0, modulus x is x. Now let us consider a limit fx as x approaches 0, where y equals fx equals when x not equal to 0, the function is defined as x over mod x. When x equals 0, the function is defined as x. Here, when x equals 0, y is also 0, which means the origin 0, 0 lies on the graph of this function. Now, when x not equal to 0, for finding left-hand limit and right-hand limit, we have to select the same function x over mod x. Therefore, to find LHL, we will write left-hand limit LHL equals limit x over mod x as x approaches 0 negative will be x over minus x. Now why minus x? Because see here, when x approaches 0 from left side or from negative side, mod x is negative. Therefore here it is minus x. So x over minus x is minus 1. Now to find RHL or the right hand limit, we have limit x over mod x as x approaches 0 positive will be x over x. Why x? Because when x approaches 0 from right side, mod x is x. Therefore here it is x. X over x is 1. So here we find that the left hand limit is minus 1 and right hand limit is 1. Since LHL not equal to RHL, we see that the limit of fx as x approaches 0 does not exist. These are the basics of finding limits of algebraic functions. In the next video, we will understand how to find limits of trigonometric, exponential and logarithmic functions and the limits at infinity. If you liked my video, please click like and share and subscribe my channel. Thanks for watching.